Video number 24, assessing studies based on multiple regression, assessing internal and external validity of an econometric model, chapter 9, Stock and Watson. So far we have discussed linear regression models, multiple linear regression models, nonlinear regression functions, chapter 4 to chapter 8, along with stata, and it was all non-technical introduction without having a compromise on econometric concepts. So today we are going to discuss another very important concept, and which is not discussed very much in our econometric models. That the model you have, whether its results are valid for the population being studied, or whether its results can also be inferred for some other populations as well. For example, if you have a microfinancing in Bangladesh and you are trying to measure its impact on people's lives, can those results be inferred for India, India, Pakistan, or not? That's external validity. But if those results from the population from which the sample is taken, and those results are valid for Bangladesh or for some particular area of Bangladesh, then we'll say that those results are internally valid. And if they are not for India and Pakistan, it means they are not externally valid. So there are some threats why we don't have internal validity of a model. What are basically issues with those, that we'll discuss in detail. Similarly, if you are growing tomato, internal farming in controlled environment, whether that yield will also be the same when you grow those tomatoes outside field, outside that tunnel. We are trying to have vaccination for COVID-19. We are trying, if for example we are trying experiments on animals, will those results be the same when we do that for human beings? So those will be externally valid. If those are only valid for the population from which the sample is taken, then that's called internal validity. But that internal validity is not simple to achieve. So California data, so class size reduction leads to improvement in test score. In my last video we have done it with stata. So whether those results are valid for Massachusetts, whether those results are valid for some other country as well, if they are valid, then we say that there is external validity. And if those results are only valid for California, from which the data have been taken, then that's internal validity. But internal validity has also issues. Why external validity is an issue? Because there are different institutional settings, there are different rules, there are different settings, there are different factors which play a role. So we must be careful whether those results can be applied to some other population as well. So what are the main threats to internal validity of a model? That's the main topic. Omitted variable bias, I have discussed time and again. If wrong functional form, errors in variable bias, sample selection bias, simultaneous causality bias. So these are 5 threats. The first one I have discussed in chapter 6, sorry, that if a variable is determinant of y and is correlated with x and you don't include it, it will lead to omitted variable bias. So if you have data, it's okay, include it. If you don't have data, then it's the issue that whether use panel data or instrumental variable or run a randomized controlled trials. These will be our next topics. Why we move to from this multiple linear regression or nonlinear regression functions to these topics? Because we suffer from these threats. Next, wrong functional form. If you have used nonlinear regression function, linear regression instead of nonlinear, so you will have wrong results. So you have to use a correct functional form. Errors in variable bias. So far we are assuming that there are no errors in variables, but We all know that all observed data, all our macroeconomic variables, microeconomic variables are not free of errors. So we have to be careful about this. What to do? For example, if we get x, not x, we get x tilde. We get x tilde. Then that means we, instead of x, we are observing this one. So this whole will be in this xi minus x tilde will be with ui. So xi tilde and this will be correlated. This will lead to omitted variable bias beta 1. Watch those previous videos, you will get the concept clearly. So it means there is biasness. How to overcome this bias? You can have better data, easy said than done, develop a good, develop a specific model of the measurement error process, or you can use instrumental variable regression. Sample selection bias, that's where I'm going to focus more. And on the next point, sample selection bias is that when you have a sample, but that's not a representative. We are going to take two examples. One is mutual fund, other one is earning function. For example, we pick mutual funds which are managed by fund managers, and we have a data of for 10 years, those which survived for last 10 years. And then we want to see that whether returns returns are how returns are linked with managed funds. So you see, after 10 years, you are picking only those which survived. You are suffering from survival bias, because those funds which were managed but they failed after 4 years, 5 years, 3 years, 7 years, 8 years, they are not included. Where they are in UI. Fund managed funds and the failed funds, both those will be here. So this will be correlated. So what's the possible solution? Pick all those funds which were available at 2010, and then keep that data, and then see that funds managed, whether their returns are higher than those which are not managed by experts. Similarly, other one is earning. You regress earning on years of education, but in earning, who are included? Who are employed? What about those who are unemployed? So you are suffering from sample selection bias. You have already picked those who are earning. So what's the solution? Pick a sample of graduates, not only employed. So in graduates, you have employed as well as unemployed. In mutual fund case, instead of picking sample after at end of the 10 years, pick at the beginning of the period included failed funds. Last threat to internal validity of a model is simultaneous causality bias, one of the fundamental concepts of any economic issue or social science issue, because we are interested why does it work, not what does work. So class size affect test score. For example, if districts having poor test scores, more teachers were hired because test scores were poor, that will lead to low student-teacher ratio. It means poor test score is leading to low student-teacher ratio, not low student-teacher ratio is causing test score. So this is simultaneous causality bias. Foreign direct investment and economic growth, export-led growth, growth-led export, all these are simultaneous, suffer from simultaneous causality biases. What are the solutions? The regression discontinuity designs, difference in difference estimators, instrumental variables. We'll keep on discussing these things in our coming videos, and this is what I have been talking about. So potential solutions, you can have randomized controlled trials for which you need a lot of money when you do it in social sciences. Banerjee and Duflo people are doing it and they won Nobel Prize on these type of contributions. So this type of experiments cannot, these randomized control trials are not possible at macro level, because we have one central bank. Whether that central bank increases interest rate or not. So we cannot say that we have 15 central banks and we say 7 don't, 7 do. So we can't do that. We can't do that. So no, in our next videos, we'll try to study panel data, instrumental variable, difference in difference estimators to resolve these problems. So at the moment, if your objective is forecasting, R square is really good. If your objective is simultaneous causality or causality, then R square and all these things are not of much use. So we'll discuss all these things in detail, how to deal with these 5 threats to internal validity of a model: omitted variable bias, a wrong functional form, errors in variables, sample selection bias, simultaneous causality bias in our coming videos. Thank you for watching. Take care.